Welcome to our class on probability. In this class, we're going to learn conditional probability. For us to understand conditional probability, we first need to go to the basics, to knowing what axioms or formulas are involved in probability. To start with, probability is simply the likelihood that an event will occur, the chances that this event will occur. And probability is applicable on a very everyday, daily basis. The chances that an accident will occur if you are reckless or if you drink. The chances that a baby will be a boy or a girl. The chances that it will rain. All these are utter probability. And today, the chances that one person will contract COVID-19 in a congested place, all that is a matter of probability. Now, there are about 15 axioms of probability. For today, I'll just dominate on 5 key axioms. Of course, I'll go through a number of them, then we'll see how we can apply them. So the first axiom or first formula of probability is simply that the probability should always range between 0 and 1. This is the probability within which a sample space must occur. The probability of an event must be between 0 and 1. Anything above that and anything below that is unacceptable. So you can never get a negative probability. You can never get anything above 1 or 100%. Then the probability of A intersection B is simply probability of A plus probability of B minus a union set. The probability of A union B is simply probability of A plus the probability of B minus the intersection set. So if you have two sets, set A and set B. So to unite is to add. So A union B, we're simply adding what A has plus what B has, then you subtract what is in between them, what is common. So in an applied perspective, if two of you are taking 3 courses and you're sharing quantitative methods, it is your 3 courses plus my 3 courses minus the course that we are sharing, the intersection set. So this is the most distinctive formula that you need to know, the union set formula. So this is A union B. Now, if you make the intersection set formula subject of the formula, it becomes the opposite. So this is the intersection set. So A intersection B is where they're meeting. So it's A plus B minus the union set. That is what will give you the intersection set. The complement is simply what is outside. Complement is simply what is outside. So if you have A and B, the complement of B is what is outside B. So complement of B is 1 minus B itself. So these axioms of probability are really important because once you understand them, any question to do with probability, you'll be able to understand. So the probability of A is 20%. The complement of A is 20% from 100, that is 80%. So that is how we find the complement. So complement is what is outside. So we are now going to Bayes' theorem. A given B, B ally upon Sherpa, then you have A intersection B on top. If you have B given A will go down, and on top we're going to have A intersection B. I repeat, this is one of the most important theorems. This is called Bayes' theorem. Under Bayes' theorem, you need to take note of the bottom guy. When the bottom guy goes down there, then you can intersect these two. A intersection B is the same as B intersection A. So whatever comes first is okay. So just to fortify on what I've just said, if you have X given Y, which letter will go down? The probability of what? Of Y. Then on top, we're going to intersect these two letters. X intersection what? X intersection Y. Of course, we as statisticians love to start with the letter which comes first in the alphabet, but it will not be wrong if you also wrote Y intersection X. That's still okay. My classes are interactive, so I need as much as possible your interaction. So if we had B given A, can somebody try? How do we expand this? What comes down? The probability of what?
A.
Probability A. Then on top, what are we going to have?
A intersection B.
Good.
Probability of A.
Probability of A intersection B. It's like a pattern. Just know this pattern. Now with this very pattern, if I cross multiply this one times that one, the probability of X given Y, if I multiply it by the bottom character, you always get an intersection. So X given Y times Y, this Y which is here, it will ultimately give us the probability of X intersection Y. So can somebody tell me if I'm going to multiply B given A times A, B given A times A, what am I going to have?
Into probability of A intersection B.
Great. It will give us a probability of A intersection B. So I wouldn't be wrong if I told you to master that whenever you have a conditional probability and it's being multiplied by the bottom character, if in an pattern, automatically you're getting an intersection. So now to be clear, to be sure whether you've understood what I'm saying, what will I multiply M intersection N to get an intersection? What will I multiply here to get M intersection N?
Multiply it by N.
Yes,
Probability of N.
the probability of N. So you see when these two are the same, we're automatically getting an intersection. So far, are we together? Then there's what we call Theorem 2. Theorem 2 simply says if you're intersecting, probability of A is equal to probability of A intersection B plus probability of A intersection B, but the common letter here is what? A. Put the common letter. In short, apanga pari A complement yala pari letter in B to be on the other letter. If here were B, the complement would be on the other letter here. A. So probability of X, therefore, using theorem 2, will be probability of X intersection Y plus probability of X intersection Y The complement will be on which letter now?
On Y.
Excellent. On Y. So apanga pali X, apaya pali Y. Alternatively, you check through which letter is common throughout. It is letter X. This is what is called theorem what? Theorem 2. So it also follows that sometimes you may not only have two intersections. If you have A intersection D plus B intersection D plus C intersection D, the total sum will be called what probability? What probability are we going to have? This is the probability of what? Excellent. Probability of the common letter, which is what? D. So this is where theorem 2 comes from. Here, X's are the same. We can't say this Y is the same because one has a complement. Here, we have D throughout. So whenever we're adding intersections, the common letter becomes the probability. So lastly, on theorem 2, if instead here I have X intersection Y plus X intersection Y, and the complement I have here is here on X, what becomes the subject? What becomes the subject? Yes, the common letter. What letter is common here? It's probability of Y. So I don't want to lose any of you here. I'm only taking you through 5 key important axioms of probability. So before we go into a question now, a recap. Number 1, what they say the probability of a complement is? If I have probability of A plus probability of A complement, what do I get? Probability of A plus probability of A complement, what do I get? One. If A is 20%, what is the complement of A? 80%. The two must add up to 1. Are you together? Okay, then I also asked if I have A given B, how do we expand this? Chideshe? A given B, how do we expand this? What goes down? Yes, Daniel? The beauty about Zoom is that I can see all the names here. So I want us to be as participative. No one will be left behind. We need to move.
Sorry, what's the question again? Sorry.
How do we expand this?
This one will be P on top there, it will be P A intersect B, then below it will be PB.
Yes, good. On top we have A intersection B, and the bottom guy will be what? The bottom character. B. Good.
Yeah.
Are we agreeing with him? Okay, James.
Yes.
Can you lead us through B given A? What goes down?
Probability A.
Good. probability of A down. Then what comes on top?
It will be probability B intersection A.
Good. B intersection A. Is he right? Yes, that's right. So this is how we expand. Okay, Mia, using theorem 2, how do we expand probability of A? Using theorem 2, what is the probability of A? It is A intersection B plus A intersection B, but the complement will be on which letter?
The B.
The other letter, all right? So it's party A, yeah, party B up. Okay. If we had B there, the complement will be on the other letter A. Is that clear? So I'm trying to make these formulas as easy as you can remember. Okay, can somebody give us a formula for A union B quickly? A union B.
Probability of A
Probability of A, good.
plus probability of B
As probability of B.
minus probability of A intersection B.
Minus probability of A intersection B. That is correct. So if you're making A intersection B, subject, they just swap positions. This one comes this side and this one comes the other side. At this point, are there any questions? Okay. Now we're going to look at this question. Expect this question in your exam, in your test. You just change the figures. These are the questions that usually come. So consider an insurer that offers two types of policies, home and car insurance. We are told that 80% of all customers have home insurance policy, and 96% of all car customers have a car policy. Every customer has at least one of the two types. Number one, calculate the probability that a randomly selected customer does not have a car insurance, has a car insurance and home insurance, has home insurance given he has a car insurance, does not have a car insurance given that he has a home insurance. So we're going to analyze this question and break it down from what we've just learned. So I must mention that the word or is the same as union set or addition under probability. The word and is the same as intersection or multiplication under probability. So this is key to note. So we've been given a question that we are going to dissect together. So this question, I'll bring it here so that we have the same screen. Okay. So now we've been given an insurer that offers two types of policy. Home, we can call this H, the probability of H, and car insurance, we can call this C. So to start with, can somebody give me what's the probability of H and what's the probability of C? At least this you can figure out from there.
0.87 probability of H.
Okay. H is 0.87, which is 87%. Are we agreeing?
That's fine, sir.
So this course, English is prerequisite. Consider an insurance that has two types of policy, home and car, right? 87% of all car insurance have a home. So meaning H is what? 87%. Then 96% of all customers have a car insurance. So car was what? 0.
0.96.
Are we all agreeing?
96.
Yes.
Okay. So probability questions look complicated if you don't understand the axioms. So we're going to move bit by bit. Then here we are told every customer has at least one of the two types. So it means when we add at least, so A, H, if we add all the customers, to add is to do what? To unite, right? H
Yeah.
union C must be equal to what? To 1, right?
Yes.
All right, and we know, how do we expand the union set for H union C? Can somebody try?
Probability of H
Mm-hmm.
plus probability of C
Mm-hmm.
minus probability of H intersection C.
Good. The same as A and B, the way we're doing it, right?
Yes.
I'll give you a minute to digest this so far. We're coming from the axiom that we just from discussing this union set A union B, A plus B minus the intersection. So here we're told that at least every customer has one of them. So when unite A union C is equal to 1, we just expanded this. Of course, we may not need this or we may need this. At the moment, we do not know. Okay. So question number 1, what is the probability that a randomly selected customer does not have a car insurance? What is the probability that doesn't have a car insurance? Okay, Sibu, what are they asking for? Does not have a car insurance. Sibu, what are they asking for? Yes, Sibu. Sibu, are you there? What are they asking for? The probability that does not have a car insurance. What are they asking for? Your network is not very good. James?
They're asking for probability of H.
Okay, you've tried a bit. You're getting the opposite. Not
Which
visit.
complement?
Yes, the complement. Does not have is the complement. So they're asking us
Oh, okay.
outside what? Outside C. What's the probability that it doesn't have a car insurance? So let me put it like this. If there's a 90% chance of having a baby boy, what's the probability that you're not going to have a baby boy? 10%.
10%.
Yeah, that's what they asked.
Saving a baby.
So what is the probability that it does? Because there are only two options available. So what's the probability that it doesn't have a kind of policy? It's just the complement of what? Of C. So we know that C is what? 96%. So the complement of C is what? 1 minus
1 minus 0.96.
which is 0. What? 0.4. Okay.
0.4.
Or 4% if you want. On this one, are we together?
Yeah.
Yes.
All right. So we're now looking at part B. What is the probability that he has a car insurance and a home insurance? Can somebody tell me what does the word "and" stand for?
That's an intersection. Sir.
Intersection.
Good.
Yeah.
So we're
Or
looking
multiplication.
for this guy here, right? Or multiplication. Excellent. So we already have the union set as 1, right? All right.
Yeah.
So we know that H union C should be equal to probability of H plus probability of C minus H intersection C. So what is our H? It's supposed to be intersection, sorry. What is our union set? It is 1, right? What is the probability of H? 0.87, right?
96.
And what is
Hmm.
C? 0.96.
96.
So now I want you to calculate the probability of H intersection C. Make H intersection C subject. I want you to calculate that quickly. I hope you have your calculators. So you add 0.87 plus 0.96, you subtract 1. What are you getting? Zero point.
I'm getting 0.83.
0.83. Confirm.
What's 0.82?
0.82.
So 0.87 plus 0.96.
Oh, 83. 83, yes.
Yeah.
83. Are we all together? Are we agreeing?
Yeah.
All right. So this is the probability of car and home insurance. Here now we're being asked to calculate the probability of.
Sorry, Collins, just a quick question. So anyway, I'm still getting the gist of it.
Okay.
So what I had done was I actually multiplied H and C right where it was.
And what did you get?
So what's the need of or why do we rather make it cross to go to 1?
Okay. So that is, first of all, if you are only given the probability of H and C alone without any other information, you could just quickly multiply them, H and C, it will give you the intersection. But if you have other underlying conditions, they supersede that basic rule. So to start with, we're told that every customer at least has one of the two policies. So this statement tells you that H union C, when we add them, they'll give you 1. If you're told that all the customers have at least 80%, meaning when you unite A and B to give you 0.8. So here we're told that this gives us 1 in short. The union set, when you combine them, it will be going to give us 1. That's why we combined, we equated to 1. Is that clear?
Yes.
So the probability of H is 0.87, the probability of C is 0.96, and the intersection is what we're looking for. So here we're looking for the intersection because we're being asked to find the probability that a customer has a car insurance and a home insurance. But just for curiosity, just for those that are curious, if you multiply these two, what are you getting? Sometimes, though coincidentally, you may get the answer.
Yes, I actually got 0.8352.
Okay, great. So, of course, to multiply, you're getting something close. So those who would write that would be close to the answer. Now, what is the probability that the customer has a home insurance given that he has a car insurance? So what notation do we write here? Probability
P
of
H
P
H
Given C.
over C.
Good, given C. So we will need to expand this. Can somebody who hasn't spoken, please expand this? How do we expand H given C? Somebody who hasn't spoken, expand this for us. Chileshe?
So it's probability H intersection C.
Good. Probability H intersection C.
Over probability C.
Okay. Can somebody confirm that? Is he right?
Yes, yes.
Okay,
Yes.
great. So now let's check from our database. Do we have H intersection C and we have probability of C? Do we have H intersection C? 4%, right?
0.83.
Okay, the intersection was 0. What?
83.
83, good. And what was our probability of C? 0.4.
0.4.
0.96.
0.96, okay.
96.
So here, 0.83 over 0.96. What are we getting?
0.86.
0.86. Confirmed?
Collins, I'm a bit behind on the probability of C. Didn't you say it's 1 minus 0.96?
That was the complement of C.
Oh, okay.
Yeah.
All right.
Here, this was the complement of C. It does not have, but here the actual C was 96%.
Okay. All right.
All right. So are we together so far? Okay, now
Getting there.
the tricky one here. What is the probability that he does not have a car insurance given that he has a home insurance? Who will lead us through the notation?
Probability of H C complement.
Good. Does not have car insurance, so C complement.
Given H.
Excellent. Given H. So does not have car insurance. It's C complement given H. So I want somebody else now to expand that. Probability of C complement given H.
Collins, just a quick one. What does a C complement mean?
A C complement, a complement to start with, we said is what is outside, what is not there. If the chances that PF will win is 80%, the chance that PF will not win is 20%. All right? So a complement is the opposite. So if you are going to have a car insurance at 20%, the chances that you not have a car insurance is 80%. All right?
Okay. Okay.
Great. So who wants to expand this for us? What goes down? Who hasn't spoken? Please, I need everyone to be on board. That's why I need as few as you can be. Our numbers should not be exceeding 15, at least 10, 15, and below, so that we all move together. Yes, Joseph. Which one goes down?
What's the question?
How do we expand this using Bayes' theorem? Which letter goes down?
Okay. Go through the question.
This, expand this in short. Mm-hmm.
So P
Mm-hmm.
Probability
Mm-hmm.
P
Mm-hmm.
and C
Mm-hmm.
intersection H
Mm-hmm.
over
Mm-hmm.
probability
Mm-hmm.
H.
Okay. So I'll give you 80%. You've missed it a bit. There's something that is missing. You're almost there. Pardon? Yes, C complement. So don't leave this cassette here. As it is appearing, put it there.
Okay.
Now it's complete. All right. Okay. So at least.
Collins,
Uh-huh. So you don't.
so the way it is, probability of C complement intersection H, is it safe to say it's just the same as probability of H, looking at the question we have?
This now brings about theorem 2. This is the toughest question here. So now to hapa. Happily, if you have probability of what? Of C using theorem 2, it is probability of C intersection H plus what? C intersection H, but complement yala beta pesa. If you remember very well. Complement is where? On H, eh? On H.
Yeah.
If we had probability of H here, we're going to have what? Probability of C.
C intersection H.
Intersection H. Plus C intersection H.
Probability of C intersection.
But the complement
With
will
the
be where?
complement on C.
Good.
On C.
So which of these two formulas will qualify to help us find the missing figure here? Formula 1 or Formula 2?
Second one. Formula 2.
Good. Because Formula 2 has what we are looking for here. So the probability of H, what was the probability of H? Probability of H is what?
Mm,
0.87, right?
0.87.
0.87.
And the intersection, point what? 83.
3.
So upper
0.83.
0.87. Then here we don't know. That's what we are looking for. Then probability here is point what? 0.83, right?
Yes.
When it goes this side, what are we going to have as a probability of C complement intersection H?
0.04.
0.04, good. .04. So this is 0.04 that we put here. 0.04. Then probability of H.
Excuse me, sir.
Uh-huh.
So I wanted to find out this theorem. Which one are we using?
We're using theorem
What is
2.
it called?
Theorem 2. Whenever we have an intersection set that has a complement inside, it is called theorem 2. So you cannot guess if you don't know these axioms. You can't even know where to start from unless you know these axioms.
Yeah. So this one, what is it called? Which rule is this?
It's called theorem 2.
Theorem 2. Okay.
Yes. I'll send you the notes after the class and I'll send the video. So quickly, you know where the 0.04 is coming from. The H, we already have it. Our H was what? 0.87, right? So
Yes.
Yes.
0.87, what becomes our final answer?
Zero point zero 0.06. 0.05, sorry. 0.05.
0.05. Do we agree?
Yeah.
Okay. So 0.05. Now, this is what is called probability in the conditional probability.